All right, Math 9, here's a short video to sum up adding and subtracting fractions. So remember, you can watch the full lesson linked to the website for operations with fractions, includes simplification, but this is just a short with a couple examples. So we'll start here. Remember that when we add and subtract fractions, we need to have a common denominator, because if you remember from the previous video, the denominator is the size of the pieces, and our pieces need to be the same size if we're going to add up however many or subtract however many we have. So that's our first step here. And in order to get a common denominator, we use the equivalence principle. So remember that I can make 7 into 14 through multiplication by multiplying by 2. But if I'm going to do that, I need to multiply by 3. This is the equivalent, or by 2 on top. This is the equivalence principle, right? So now we end up with 6 over 14 plus 5 over 14. And now since we have the same sized pieces, we just add up however many we have. We have 6 of them, we add 5 of them, we end up with 11 of that size. You don't add the denominators, obviously, because the denominators are the size of the pieces, and the size of the pieces don't change when you add up the ones you have. So here's another one, subtraction. We can multiply 5 by something to get 20. So in these cases, we only need to change one of the fractions. It makes life a little bit easier. We don't have to worry too much about the lowest common denominator because we're only adapting one fraction. So in this case, we get 8 over 20 minus 7 over 20, and we end up with 1 over 20. So let's look at a couple more. Now remember that when you have mixed fractions, it's very, 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 very helpful to convert to improper first. Because yes, the addition might be straightforward, but when you get into things like the subtraction or multiplication, using mixed numbers can be very confusing. So it is my strong suggestion that your step one should be convert. So remember, take your denominator, multiply it by your whole number. Now, if you can't remember this, there's a short video on this mixed to improper, and then there's also the full lesson. So pop back and have a watch. But 12 and then plus 2, so we get 14 over 3. And then plus, so multiply that, 8 times 2 is 16, plus 5 is 21, 21 over 8. So now we're looking for a common denominator, and sometimes you can get one that is not just the multiplication of the two with each other, because you can see here, if I multiplied 3 by 8, and I multiplied 8 by 3, that's a guaranteed way to always get a common denominator. Multiply the denominators by each other. We don't always need to do that. I have a couple examples here, but in this case we do, and we will. So 14 times 8 and 21 times 3. So here's where you use your multiplication table if you're struggling with 14 times 8, 80 and 32. So it's 112 over 24 plus 63 over 24. So now we have common denominators, and we can add these things together. So 112 plus 63 is 175. And now we get into that point where, hey, can we simplify this thing? Now, you don't need to convert it back to mixed. I'm happy with an improper fraction. But think about 175. It's divisible by 5. So this is where it comes down to factors again. So 175 divided by 5 gives you 35. And 35 is just 7 times 5. So it means if 175 over 24 is simplifiable, it means I have a factor of a 5 or a 7 in the denominator. But 24 is just 3 times 8, and 8 is just 2 times 2 times 2 times 2. So that cannot be simplified down. So we'll leave that there. So now let's look at the next one. Remember that the negative implies negative quantity. It does not affect our conversion into an improper fraction. So 7 times 2 is 14, so we do that first. Plus 3 is 17 over 7, and minus 4 over 9. We don't change that one. Now again, if we look at the numbers 7 and 9, lowest common multiple is going to just be the product of the two. So multiply by 9, multiply by 9, multiply by 7, multiply by 7. So now we're going to be guaranteed to get a common denominator. So you can use your multiplication table for this one. We have negative 153 over 63 minus 28 over 63. And now here we are at an integer question, right? We have a negative 153 and we are subtracting 28. So remember that if we can change this into an addition statement, subtracting a positive is the same as adding a negative, right? Those are equal statements. So now we're just adding these two numbers together. 153 plus 28, 11, carry 8, 181. The only difference is we added two negative numbers together, so we get negative 181 over 63. Now 63 is only divisible by 7 and 9, which means 9 is 3 times 3. So if I can divide 181, you only need to try to divide it by 7, doesn't work, or by 3, doesn't work. So you know that that is simplified. If what I just did there is confusing with simplification, watch the video on simplification, but it's about identifying common factors. The factors of 63 are 7 times 9, and the factors of 81 would have to cancel with one of those two things. But 9 is just 3 times 3. So if I can divide 181 by 7, it'll factor. If I can divide 181 by 3, it'll factor. But it doesn't work in these instances, so we cannot simplify my fraction. Pay no attention to this title. You can see on the past couple pages it says simplify before you multiply. I'm not really sure why, so don't worry about that. Okay, and don't worry about that because we're not multiplying, and don't worry about that because we're not multiplying. Maybe it should say get a common denominator. So here's a classic video fail for you. These happen, but why start again? We'll just go from here. So now we need a common denominator, and we have a whole bunch of fractions. First thing I would do is I would convert my mixed fraction here into improper. So now I have 2 over 3 minus 4 over 9 plus 5 over 6 minus 5 over 2. Now you can actually combine these piecewise. You can do some with some before you do them all and just kind of see maybe things will cancel out. So what I'm going to do is I'm actually just going to do this from left to right, and you'll see that 2/3 minus 4/9. So I'm going to need this to be a denominator of 9. So I'm just going to do this one first. This becomes 6 over 9 minus 4 over 9, and then plus 5 over 6 minus 5 over 2. Now I can do the first one, 2 over 9, but you'll notice, yeah, it didn't really simplify. I can't simplify 2 over 9, so it didn't really help me out. But what I'm looking for now is I'm looking for a common denominator between 9, 6, and 2, and it is 18, right? I don't need to multiply them all by each other because 9 times 2 is 18, 6 times 3 is 18, and 2 times 9 is 18. So that's going to be my common denominator. So we'll go there here. We'll multiply this by 2, and this by 2, this by 3, and this by 3, and this by 9, and this by 9. So what do we get? We get 4 over 18 plus 15 over 18 minus 45 over 18. And then we just do this from left to right. So 4 plus 15, so we get 19 over 18 minus 45 over 18. Now here we are again, back to our integers question, right? How do we add and subtract these things? And remember that when you are subtracting a bigger number from a smaller number, and in that I mean the 45 from the 19, the difference between those two numbers will be the same as if you subtract 19 from 45. The difference between them is the same. The only difference is my answer positive or negative? So I need to borrow 15. So 15 over 9, minus 9 is 6. 3 minus 1 is 26. The difference between 45 and 19 is 26, but in this case, since I'm subtracting the 45 from the 19, my answer is negative 26 over 18. And now if we consider simplification, 26 and 18 are both even, so I'll divide them both by 2. I'll demonstrate it this way rather than breaking it down into factors. And we get negative 13 over 9. 13's prime, so you know we're done. So that's the short video. Again, weird on the titles, but we'll just adapt. Adding and subtracting, we need a common denominator. We need to convert from mixed to improper. And then it's making sure that we have our integer game on point. Okay, thanks so much, and see you next time.